The new component in entity ER diagram is called a hierarchy relationship. This is a special kind of relationship. Okay? So much like inheritance in object-oriented programming, which I assume all of you have some experience with, like you have written some code in Java or C++, you must know what class is, what object is, and all that. And there is this concept of inheritance, right? You have parent class, you have children class. You have car, then you have sedan, you have SUV, sedan, SUV being the children class of the car class. That's an example of it. You follow me? So similarly, in ER diagram, we want to model this potential hierarchical relationship among objects, among real-world objects. Give you an example of that. I have the employee object. And I model that using the employee entity set. So each employee becomes an entity in my employee's entity set. But among my employees, I'm going to classify them into two different categories. I have part-time employee, then I have contract employee, meaning full-time. But nevertheless, they are both employees of my organization. Because of that, they share some common attributes that I care about. For example, for each employee, I care about their SSN, I care about their name, I care about their lot. This lot can be their designated parking lot or office lot. Right? You can interpret this either way. It's an attribute I care about that. And it's common to all types of employees, regardless whether you are part-time or full-time. I want to know your SSN, I want to know your name, I want to know your lot number. Okay? In addition to that, I have class-specific attributes that I care about for different classes or different categories. That I care about for our employee, their hourly wages, and the number of hours they have worked for the organization. For contract employee, on iOS, I only care about something called contract ID. Of course, this is kind of like an artificial example, right? You can imagine I may care about the details of the contract, like the agreement, the salary, and all that stuff. I represent all those using a simple attribute called contract ID for illustration purposes. The point is, you care about some class or category-specific attributes for each of these different categories of your parent entity set. You follow me on that? So it's very much like the inheritance relationship you have seen from object-oriented programming paradigm. Right? You have car, sedan, SUV. Right? Kind of like that setup. So the way you represent this is use a triangle shape. And you write is a, ISA, to represent such hierarchical relationship among you entities. We have an example of this in our homework 1, problem 1. We have animal, we have male and female. For male and female, we care about different things. So natural design of that is you have animal entity set on top, you have male and female children entity sets. You follow me? One more thing I'd like to highlight, which is not shown in this slide, is that these are just typical, even though they are organized into a hierarchical structure, they are still just normal entity sets, all three of them. So meaning that you can still introduce normal relationships between those entities. I can have a relationship between our employee and contract employees. I can also have a relationship between our employee and employees. The normal relationships set. I can still introduce those normal relationships among any of these entity sets, in addition to the hierarchical relationship they already have. You follow me? Okay. So that's one point I'd like to clarify. Okay. So there are two types of constraints we want to clarify or add to a hierarchical design. One is called overlap constraint, meaning can somebody be our employee at the same time a contract employee. This may happen in an organization where, for example, I work for University of Utah in the computer science department. I have a full-time contract with computer science department, but in addition to that, I do some hourly consulting work for some other department on campus. So I'm both an hourly employee as well as a full-time contract employee. So in that case, overlap is allowed. But in some other organization, you may argue, the user tells you that, okay, in my organization, either it is an hourly employee or a contract employee. I don't have both. You follow me? In that case, overlap is not allowed. So how do you specify this? Well, in your design, you just add an annotation to it. You say overlap constraint allowed, overlap constraint disallowed, to clarify, that design aspect. Now, covering constraint imply whether the union of the two, for those two children entity sets, whether the union of the two covers everything for the parent entity set. Okay, in this case, most likely covering constraint is true, right? I have hourly employee, I have contract employee. The union of two is represent the population of my employees, the full population of my employees. In the car example I mentioned earlier, car, sedan, SUV, the covering constraint is not true, right? Because in addition to sedan and SUV, I may also have another category called truck. That's also a car. So if you just union sedan and SUV, the covering constraint is not true. You follow? And you may wonder, okay, why you want to have a design with car as parent entity set and sedan and SUV as children entity set? Why don't you add another children entity set called truck? Why don't you cover the entire space? Well, maybe for my dealership, I only have sedan and SUV. I don't care about truck, even though potentially you have truck as a category, but I don't care. So you see the needs where, in some cases, I just want my current constraint to be not there. Do you follow? Okay. Okay. All right. So that's hierarchical relationships. Finally, the last thing I want to introduce is called aggregation. So far, what we have seen is relationship set. You can introduce a relationship set between two or more entity sets. You can never introduce a relationship set between an entity set and another relationship set. You follow my argument? That's invalid. By the way, never do that. Okay? And even though after repeated discussion in the past, every midterm I saw some solution where we have a relationship set connecting an entity set with another relationship set. That's not allowed. Doesn't make any sense. If you were to do that, what you end up with is you have an entity with a relationship with another relationship. Kind of like that. Doesn't make sense. Okay? You only introduce relationship between entities. You don't introduce relationship between an entity and another relationship. But in certain cases, you might want to do just that. And how do you do that? I'll give you an example of this. Very simple setup. I have projects, I have departments. And each department has a budget, and I have many different projects, and department has the choice, each department has a choice of selecting a subset of project that department wants to sponsor. Do you see that? For example, border security is a project, and I can ask Department of Homeland and also FBI to each chip in some budget to co-sponsor that project. That's an example of it. You follow that? Okay. So this is kind of a simple ER to capture that. Okay. And each project has a budget. Of course, the total sponsorship a project has to secure must be equal to this, and the total number of sponsorship coming out of the department must be less than or equal to its operating budget. Those are additional constraints you will have to specify using constraint checking that we will later talk about how to do that. but there are some implicit business constraint, as you can imply, already from a simple ER like this. Do you follow that? But that's not the focus point, the focal point I'm trying to illustrate using the example. What I want to illustrate is this concept called aggregation, when you want to introduce interaction between an entity with another relationship rather than another entity. To build on this example, right? Whenever money is involved, you want to have auditing in place, right? You want to make sure money is well spent for a good purpose. You follow that? Otherwise, you're gonna have potential corruption, waste, and all that stuff, right? So you wanna have another entity like an auditor to oversee the spending of the money on this purpose. Do you see the argument? That's an interaction between an entity. So I want to have some employee to monitor this money spending activity. However, you are now in a dilemma where you want to introduce this relationship called monitor, right? Relationship set. But should this be attached to product or should this be attached to department? Neither is ideal. Because I don't want to monitor product, I don't want to monitor department. I really want to monitor this sponsorship between department and product. Do you see the argument for that? So essentially you're saying, I'm going to introduce a relationship between an entity, which is an employee entity, with this sponsor's relationship. But I just said we cannot do that. You cannot connect an entity with another relationship through a relationship. You can only connect entity with entity using a relationship. So what do you do? Well, you make this whole thing, down below, you make this whole thing a conceptual entity set using aggregation. You say, okay, I'm going to conceptualize the whole thing as a super entity set. Now I can introduce relationship between another entity with this conceptualized entity. And this conceptualized entity captures everything go within it. Okay? So this is called aggregation. Okay, that's everything you need to know about ER. Now I'm gonna use the next 5 minutes to talk, 5 to 10 minutes maybe, to talk a little bit about some of the design choices you may have. Some of them can be tricky, like should I model something as an entity or attribute? Should I model something as an entity or relationship? Or should I choose binary or ternary relationship? Should I use aggregation or not? I'll give you an example, hopefully, in each category, right, to kind of clarify, motivate the discussion. The first design choice you may face is entity versus attribute. Should I model this as an entity or should I model this instead as an attribute? A very simple example of that is, for example, when you are designing the employee entity set, and you say, I care about where my employee lives at. So you want to introduce, in other words, you want to introduce the address as potentially an attribute to your employee entity set. Is that right? You follow the argument? So naturally you want to use address as an attribute for employee. However, just if, okay? What if one of the following is true? In the first case, let's say each employee may have multiple addresses. That's possible, right? I may have 2 houses, or another employee may have a couple of locations. And furthermore, the number of possible locations for employee is a variable. It's not a constant. Some may have 2, some may have 3, some may have 4, some may have most of employees may have just 1. So if you were to use address as an attribute, you face a dilemma, right? You have to introduce not just one address attribute, you have to introduce maybe up to 5 address attributes to cater for that worst case scenario, because the employee in the worst case may have up to 5 locations. But if you go with a design like that, vast majority of your employee records end up wasting many address attributes, because most of them have only 1 or 2 addresses. But in order to cater for that worst case, because you are dealing with structured data, meaning all records of your design must be of same structure, we all end up with 5 address values. You see the problem with that? So a potential fix to that is what? Is to, instead of modeling address as an attribute, you model address as another entity set. Now you can introduce relationship between employee and entity set. Now each employee can have as many interaction with different address entities as you wish. Some may have 1, some may have 2, some may have 5. That's fine. You see the argument I have? And another benefit of this is multiple employees may share the same address entity. They may live in the same apartment complex or share a house, I don't know, right? So that get rid of some duplication if you were to model address as an attribute. Because if you were to model address as an attribute, then all those employees who live in the same address will end up duplicating the address value. But now they are all just connecting to the same entities through different relationships. So that's another benefit. Yet another benefit of modeling address as an entity set is that you can have substructures within address. Because now you can, because once address becomes an entity, you can have different attributes of this address. Meaning that instead of modeling address as a string value, which you don't know what the structure is, the string is unstructured, now you have different attributes. You can have, for example, street name, apartment number, state, country. These are structured information about your address. If you model address as an attribute, as an entity. So those are the benefits that you will have if you go with entity, right? But if you don't care about all those, if you don't care about structure within address, and each employee, in most cases, the most common scenario has only 1 address, then modeling address as an entity set is a waste. You're overcomplicating your design. So in that scenario, you should just model address as a single attribute to the employee. So it really depends on, unfortunately, there are no golden bullet I can provide to you, say, okay, use this checklist. If it's like this, do this. If it's like this, do this. You kind of have to, on the spot, spontaneously figure out what is a good solution you want to come up with as a DBA, database administrator, or database designer. Okay? There's no kind of like simple checklist or cheat sheet I can provide to you, say, just check against this. Okay? You have to improvise, okay, based on the user requirements to figure out what is the best design for you. I will introduce another example to you, then I will stop here, and the remaining ones I will ask you to explore yourself. Okay? And in this example, suppose I have employee and department. And I say employee worked in that department from 2. From and to both are dates attribute. Represent the start date and end date an employee has worked for a particular department. Okay? That's the design on top. So what is an implicit constraint of that design on top? Or let me ask you another way. Can the same employee works for the same department more than once over different periods of time? Using that first design, you said no. Can you explain why?
Because it's an attribute, so you can't have more than one instance of it.
Excellent. Because in your design, you choose from and to as attributes of that relationship. You only can have one instantiation, one value for each of that attribute. And what you didn't mention though, on top of that, is that every two entities can be linked by the same type of relationship only once. In other words, if I draw this using a graph, what it looks like is I have employees. This is employee 1. Then I have department on this end. Department A, Department B, Department C. Now, let's say employee is a managed many. So employee may work for Department A, may also work for Department C. Now I have attributes. Okay? Say 1, 1, 17 to from and to. You follow me? And this one could be, I don't know, like March 1, 16 to October 26, 16. And they may overlap because I have no concern saying that you cannot work for the same department at the same time. But in this case, let's say the two durations do not overlap. That's okay. The point is, you cannot connect the same entities. You cannot connect the same entities with the same type of relationship more than once. Meaning that you cannot introduce another interaction of the same type for the same two entities. You follow me? That prevents you from modeling the fact that this employee may end up working for the same department again at a different duration. Yes? So how do I capture this? If I want to say the fact that this guy works for this department from 15 to October 1, 16 as well. How do I do that? Using the current design, impossible. You cannot do that. Okay? How do you fix this? Well, use the design at the bottom. You model duration as another entity set. Then introduce a ternary relation set. Why that fix helps? Because the picture is going to be different. You no longer have this. What you have is another entity down below. Each of this is a duration. Each of this has a from and to. Let's say this is and this is January 15 to October 26, I said? 16. These are two different durations. This has another duration, whatever it is. I don't really know. Now, the design I have just now becomes, I work for you. For this duration, I also work for you using another duration. And then I work for another department at another duration. This becomes three separate relationships. Okay? You follow this example? Why this is fixed? Okay. And there are some other kind of examples I will ask you to go over yourself. ER can become really tricky. Here is an example of it. And this is from U.S. Department of Interior Bureau of Land Management. But of course, don't take this as a I hate to make this, but I cannot stop. So government always overcomplicates things. So if I were to design this, I probably can think of it as quite a bit, but still it's complicated. And this is just page 1 of 2. That's what I mean by government always overcomplicates things. Okay? All right. One last thing before I move on to the next topic. Meaning ER can get really complicated. Okay? If you don't trust me, wait until you project phase 1 is out. By the way, I will set up a Google Doc for you to set up your project team information. If you cannot find a partner by yourself, that's fine. Simply put your name down. We will do random pairing at the end for those who do not have a team yet. But if you know who you want to work with, go ahead and enter your team information into that document. The last thing before I move on to the next topic of today's discussion is, by the way, I will post this on Canvas as well. Is something called cross-food. So keep in mind, there are many different standards people have used to draw a ER diagram. The underlying structure or principle is the same. You have entity set, relation set, you have one-to-many, is all that stuff is the same. Total participation constraint, everything is the same to what we say, but they may differ in the way they represent them. The picture representation of one-to-one, many-to-many might be slightly different. Do you follow that? The one we discussed in lecture is one popular model. Another popular model, there are many different alternatives. There's no way I can enumerate all of them. I just want to bring your attention to another popular model that people use in the literature so that you don't later on go see a ER diagram and say, hey, Fifi never taught me that. Okay? Is called cross-food relationship symbols. I will upload this to the Canvas, but it gives you this mapping like what each symbol means. Like one-to-one, zero-to-one, many-to-many, what's the relationship, what it is, etc. You follow that? And the principle is identical to what we have discussed. Okay? So you will see this yourself later on. And this is just FYI. Okay? You don't have to actually learn this or master this for the purpose of this course. But really later on when you go on design and you want to make a living for database. Okay? If you want to make a living out of database, you might want to know this. Yeah, go ahead.
Can we use either one on an exam?
Say again?
Can we use either model?
No, you have to use the one I teach in class, not this one. You cannot use this one in exam. This is just FYI. Later on, when you graduate from this course, when you go on work and you see something you don't like puzzled, like what's this?
Do you have a sheet like this for the one that
I will upload this to the class.
Do you have a sheet like this for the one
just
that
look
you
at
taught?
the slides is much better than this. Right? Just look at the slides.
All right.
Okay, so that's that. Let me move on to the next topic. So, if we pause for a little bit, think about the discussion we have so far. We talk about relational model. We understand what relational model is. Relational model, as some of you may say, is just tables. Then we talk about ER. And I emphasize a couple of times in the discussion of ER, and when you are designing your entities and relationships, do not think about tables. There are no tables. There are no table whatsoever in that process. No tables. Okay? Now, eventually you need to connect the two. Your ultimate objective is still to create tables. ER is just a way to formalize your design so that you can have a clean design when you convert them to tables. Okay? So the next topic of discussion naturally is, if I already have my ER diagram, my ER design, how do I convert that to tables, to relational tables? Unfortunately, this part is very, how do I say it, mechanical, meaning that there's a very strict process, straightforward process you follow, like kind of like a cheat sheet. If it's like this, you do this. If it's like this, you do that. There's not really much freedom in this process of converting ER to relational model. Pretty much once you have finalized your ER diagram, you follow this procedure, you get more or less one particular relational model design, meaning a collection of tables. You follow that? That's what I'm going to talk about next. Of course, you may argue, hey, why not I just grab you the specification, like something you see from your homework one, and go from there directly to tables, skipping the ER and ER conversion table altogether. It's possible to do that. However, oftentimes if you do that, you end up with kind of like a spaghetti design. You have a bunch of tables, not well formulated, not well formalized, and you end up storing way more information than necessary. So So that's why people typically do not go that route. I want to comment a little bit more on that route, right? Which is, it always kind of like a patch hack kind of solution. It kind of always works. But sooner or later, you will realize that design is a bad design for a lot of reasons, which we will discuss later on. We will have a dedicated discussion on that called schema refinement or schema normal form. That's the terminology we use. And I will explain a little bit more why that route is really a bad choice. Why you need to really go through this ER then table process. Okay. So that being said, let's look at how we convert a ER diagram to a table. Let's start with the basics. The basic number one is an entity set. The rule is very simple. Okay, just remember this. Every entity set converts to a relational table. That's it. Period. If you have 10 entity sets in your design, you have 10 tables. If you have 5 entity sets in your design, you have 5 tables. The schema of each table maps to the schema of your entity set, meaning those attributes of your entity set become attributes of your corresponding table. And the key of your entity set becomes the key of your table. Of course, in addition to that key, you may have additional keys. Those are candidate keys. Those become candidate keys. And the specific entities become records of your table. Of course, keep in mind in the ER diagram, whenever I draw this, I'm just using this as an illustration purpose, right? In ER diagram, we don't have this. We don't have specific instance. We only have the abstraction on top. Meaning that the converter will only give you the schema, but not the table instance, because we never really care about the specific entities in the design of ER diagram. We stay at that abstraction level of entity set, relationship set. We never care about the specific entities. You follow what I said just now? So this is just an illustration. In reality, what you get is that, the entity set, and the schema. That's it. You do not have instance involved. You do not know what kind of instance you have. And that's what happens in user requirement, right? When user give you a design document, he or she will not give you instances. Like University of Utah asks you to design a university database talking about, oh, we have undergrad, we have grad. For undergrad, we care about this. For grad, we care about that. They will not give you a list of undergrad students, trust me, in the design process of it. They may give you a few dummy records for you to help you understand what's going on. Right? But it will not give you a real instance in the design phase of it. What about relationship sets? By default, you convert relationship set to table as well, with some exceptions. I will talk about those exceptions later on. But now let's take this simplistic view that each relationship set will be converted to a table. Each relationship set will be converted to a table. Of course, keep in mind with exception I will present in the next few slides. Okay? So the way you capture relationship set is the following. This is for the work scene, right? So let me reproduce that example here so that you guys know exactly what I'm talking about. So imagine I have a binary relationship between employees, which has SSN, name, let's say lot, with work scene, with department. And I have BID, name, department name, and let's say budget, department budget. And that's my kind of setup, right? And I want to capture the fact that employee works for a department starting from a particular date. Since when you work for that date, or work for that department. And per the discussion earlier, this design allows an employee to work for a department only once. Right? So far so good. Everybody on the same page? By the way, if you have questions, just interrupt. Okay? Now, this will be a table, employee table, with 3 attributes. This will be a department table with 3 attributes. So the question is, what about this works in relationship right here? You convert this to a table as well. This converts to a table of the following schema. You take the keys from both participating entity sets. You take the keys from all participating entity sets. In this case, the binary relationship set all means just 2. So you take SSN and DID, as well as any relationship set specific attribute into this table. In this case, there is only one, which is thing. So that will be your table. That will be your table. The schema will be your table. The next critical question is, what is the key for this table? What is the key for this table? In order for you to find a key for this table, fundamentally what you need to find is a combination of attributes that can uniquely identify any record instance of this table. Right? That will serve as your key. What are the records going to this table, by the way? What are the records going to this table? Can someone answer that question for me? What records going to this table? What are those? In other words, what each record represents in this table? Do they represent an entity? Do they represent a relationship? Do they represent what?
An employee.
Okay? Are you saying each record here represents an employee? No. Okay. I'll give you a chance to try your response. Huh? Not sure?
Wouldn't be like each record's a relationship.
Excellent. Each record represents a relationship, represents an instance of this relationship. If I draw this out, this is many to many, by the way, right? What are the records here? There's nothing else but these lines. So you're going to have 5 records. One for each of these lines. Go ahead.
So you take the keys from each. You take like primary keys and candidate keys, all of those, or
just one of the key, either primary key or candidate. Typically, we take the primary key.
You just need a key.
You just need a key. Yeah, that's right. Yeah, go ahead.
In this example, it seems obvious that since is an attribute of the relation.
Yes.
But looking at the homework, then I'm having a hard time distinguishing whether the attribute should be on the relation or maybe one of the end entities.
You mean whether to put things as the attribute to the entity
Yeah.
or to the... Well, in this case, actually, a very natural choice. Things should be an attribute of the relationship because you are describing a property of that interaction, not the object itself. So that being said, it should be an attribute naturally for the relationship, not for one of the entities.
Right, in this case, then that seems to be obvious.
Yeah, because if you were to attach things to employee, it doesn't make sense because my employee may work for multiple departments. What do you mean trying to use one attribute constraints to model the fact that he may work for multiple departments with different start date? You cannot do that. Okay? All right. Now, let's try to understand why we take these 2 keys, primary key, SS and DID, as a key for this record. The fundamental reason is, in order to uniquely identify this line, this record, in order to distinguish this interaction with the rest, all you need is what? Is to know that it's connecting these 2 entities. Because earlier we said For the same type of relationships, and for two same entities, there can be only one relationship connecting them. You cannot have this. Right? That's what we said. Is that right? You follow my argument so far? Because of that, to uniquely identify a line, all you need to do is to identify the two participating entities. These two are equivalent. You follow my argument so far? If you have a question, you should raise that question now. Okay? Let me repeat. Because of the constraint that there can be only one relationship of the same type. Of course, you can have, in addition to work C, I may have managed, right? That's a different relationship. In that case, it's okay to connecting the same two entities because there are two different relationship types. Go ahead.
Are you going to get into the duration entity?
I will talk about that example later. That's a ternary relationship. Let's focus on this binary relationship for now. Now, because of that, I know for the same type of relationship, there can be at most one line connecting the same two entities. No matter whether it's one-to-one, one-to-many, many-to-many. There can be at most one line connecting the same two entities. No matter whether it's one-to-one, one-to-many, many-to-one, or one-to-one. And because of that, to identify a line, to uniquely identify a line, a relationship of a particular type, all I need to know is the two participating entities. So far so good? Now with that being said, how do I identify the two participating entities? All I need is their keys. I don't need the whole copy of those two records. I only need the copy of the keys of those two entities. Henceforth, my design for this table are the two keys to uniquely identify the two participating entities as well as any relationship-specific attribute. Okay? We all follow this argument, how we arrive here, why we are doing this. Okay, fantastic. Naturally, this becomes your key for this table. You need a combination of the two. And in addition, each of this becomes a foreign key referencing back to the two tables for the two entity sets. Henceforth, you come up with the design on top. Yes. Okay? Foreign key, foreign key. Okay, I'm going to pause for a while and open for questions. Any questions on this particular discussion so far? Go ahead.
I'm a little confused on the sense and why it's in the regulation, because it's not a key.
It's not a key, but it is a relationship-specific attribute. Meaning that in order to identify this line, yes, you only need the two keys, but each attribute is also attached with an attribute, with a value, right? Things. And you need to capture that in your record. Each of these lines come with a value, right? That should be part of your record. Question over there?
Sorry, so on the slide it says like the set of attributes. So like SSN, DID, form a super key, but it's also, in this instance, it would be a key, it would be the key.
Yes, I should have simply say. I mean, okay, there's some truth to this. I will come to this one later on because obviously it's a super key.
Yeah.
In most cases, it's actually also a key, but in certain cases, you only need one of them, depending on the kind of constraint, one-to-one or one-to-many or many-to-many. But for now, let's consider this just as a key.
Because it's a many.
If it's a many-to-many, it's a key, for sure. It's perfect. Okay. Now let me move on. Exactly to follow up on your question, the key constraints. Right? Remember, for relationships that we talk about many-to-many mapping. And that work thing is an example of that. An employee may work for multiple departments. department may have multiple employees working for that department. So it's a many-to-many setup. Sounds good? But we may have, in addition to many-to-many, we have one-to-many, or many-to-one and one-to-many are the same. They are symmetric. If you know how to work with one-to-many, you should figure out how to work with many-to-one, right? And one-to-one is a really special case. I will reserve that to the last. So here is a one-to-one. Here is a one-to-many. Why is one-to-many? Because each of this map can potentially map to many, but here each of this can map to just one. So it's one-to-many. Here is many-to-one, many-to-many. You represent one-to-many with the arrow coming out of the many side. So that represents a one-to-many many. An employee can be a manager of multiple departments, but each department may have at most one manager. At most means that you don't have to have a manager. Because I don't have total participation constraint on the department end. So far so good? All of you on this? Okay? At least you need to understand what's going on so that I can present the next discussion, which is the exception I talked about earlier when converting ER design to relational tables. Okay, for many-to-many, you go with this. You convert the relation set to a table, and you take the keys, and those combination of the keys become the key of your relationship set table. But for one-to-many, there's a problem, right? Imagine this is not work seen anymore. This is manage. And it becomes a one-to-many map. I change the discussion, okay? And I keep the same attribute called things. I want to know when you become a manager of a particular department. Now this picture needs to be updated because it's no longer a manage-many. What you end up with is something like this, one-to-many, right? So it's possible kind of like that. The first employee is the manager of 2 departments, the third employee is the manager of just 1 department, and there are also 2 employees who are not manager of any. I may also potentially this is fine, but I may also have another department without manager because I don't have total participation constraint. Either this or this is fine. Okay? It doesn't change the discussion we're going to have. Is that okay? So far so good? Let's say I add 1 to this. Let's say I have a department without manager. This will later on become important for another case I'm going to discuss. That's my setup. Of course, you can still take the existing approach. Employee goes to a table, department goes to a table, and the relationship that manages goes to a table itself, where it has SSN, BID, and things. Sounds good? Yes? This works, however, it overcomplicates things for the following reason. If you look at this particular setup, what can you claim about the DID value in the managers table? Go ahead.
It's a key.
It's a key, yes, but why is it a key?
You can't have duplicates.
You cannot?
You can't have duplicates.
You cannot have duplicate DID values. Why? Because each department can have at most how many managers? 1. That goes back to the question you had earlier. Why I said it's just a super key, not necessarily a key, because it depends on whether if it's a manage, it is a key for sure. But one-to-many, not so sure because of that. But at least it's a super key. So, U design becomes, this is no longer right. You need to update your design with this. Your key is just the idea, not the combination of the two. Because of what he said, what he has observed. You follow the discussion? Okay, if that's the case, so the subtle but really important difference. Because if you go with a design like this, go with the deal like this on the manager table. This does not map to this because you are saying a department may have multiple managers. So don't underestimate the importance of the length of this line. Can make a huge difference. If I'm a manager of the department, if I'm a sitting manager of a department, if you extend that line, I'm not happy. Because you introduce another guy who compete with my job. If I'm the president of the US, you extend the line, I say no. Yes or no? You agree that? Well, in the country example, you change department ID to country ID, person name. You see the combination is the leadership of that country. That's essentially saying each country may have multiple presidents. But in reality, what happens is just this. You only need the country ID to uniquely identify the leadership. There's one president, as far as I know, most countries have just one president. And you want to stick with that, right? You don't want to have multiple guys fighting over power, right? Do you see the difference? So it's a subtle, small, but really, it's a small but subtle and important change, and the difference. Okay? You follow what I'm saying? Now, for this discussion, what if I change my design like that? Okay? Pay attention, okay? I started with this. Now I cut line this way. I only have SSN as the key. What do they imply? Do they imply this?
No, you just flip it. Though.
It imply the flip of it. But can you interpret this for us? What semantically, what does it mean?
It's a one too many, like one.
It's managed one.
Well, so a department can have many
Can have multiple managers,
but a manager can
the
only manage
employee
one.
can be a manager at most one department.
Yeah.
If you flip the design, you cut line this way, it means totally different things. Do all of you follow this subtlety I was presenting here? Okay, fantastic. Let me go back to the original one, original case we have. One to many, okay? One to many. Arrow coming out of many side, arrow coming out of many side. If you cannot remember this, repeat it 3 times. Magically, you will remember it. And it will translate to a design like that. Okay? So far, so good? Now, the question is, the next question, if you understand all I'm saying so far, the next question is this table really, really necessary? Do I really need this table? Well, if it's hard for you to figure out the answer to that here, look at this instance here, this picture here. At the end of the day, what you care is the following: to be able to uniquely identify each of these lines somehow. If it's a many-to-many, they cross over like crazy. Okay, fine, I reserve a separate table for that. But if it's a one-to-many or many-to-one, simple case like this, do I really need to have another table for it? Well, if you think about from the department's point of view, each department record or each department entity now is a department record in the department table. Okay? Each department is able to uniquely identify its manager because I have just one manager. If I were to just extend this record with one more attribute called SSN, not only I'm able to identify my department, I'm able to identify the line attached to me. Because there's only one manager. I use one SSN value. I take the key from the other side and place here together with department record. I'm done. You follow this argument? Of course, you don't have to, you cannot just take this key, you have to take the attribute as well. Whatever attribute attached to that line. Question over there.
Said you could have departments with no.
Do you mind speaking a little bit louder so everybody can hear you?
Said you could have departments with no managers, so we could have like a default
If you, what you're saying, if you have a department who do not have manager, what's the value of that?
Yeah.
Yes, the default value will be null. Null value. Okay, excellent observation. Now, do all of you follow this? In using that design, I no longer need to create a table for this, but rather, for the department table, I'm going to modify the design of the department table, which start with just these three attributes, where department ID is the key. Let me finish, I'll take your question. Append SSN and things to this. And by the way, the key stays the same. In order to uniquely identify this dot as well as the line, I only need the department ID value. Do you follow the discussion so far? So in this case, I no longer need that table in the middle for the one-to-many case. Similarly, for the many-to-one, the same. To summarize, for one-to-many, you take the key from the one side, and place that into the many side. And then you're done. You don't need to create a table for that relationship. Yeah, question?
But if it was the...
Do you mind speaking a little bit louder so that I can hear
If
you?
it was the... I might be confusing the one-to-many, many-to-one. If the
Is it
department
a
had
many to one?
If the department had multiple managers, then would you move it to the other side?
So what you're, okay, let me clarify with you. What you mean is if I flip this, I have something like that, right? Like this. What happens, right?
Yeah.
The picture will be like that.
Yep.
Fine. You take the ID and things to the employee to make a record.
Okay.
Do all of you follow that? In that case, this table will be modified, but not that table. You may wonder, lastly, before you have a question, but I will say this out and then take the question, which is, you may wonder, okay, let's go back. Okay, I'm going to erase this if you are clearly. Okay, good. Let me go back to the one we were discussing, one-to-many. Now, if you understand all the things we said so far, you say, okay, let's go back to look at, let's add that back in, add the working relation back in, and it's many-to-many. Okay, you say, okay, for that one-to-many, you do this trick, you fix it, and you keep, instead of having 3 tables, you only have 2 tables. Fantastic. Less table, better. Now, for the worksheet, you say, can I try to do the same? Meaning, used to be we create a table for this, right? We create a worksheet table like that for the management, right? That's what we said. You may wonder, now knowing this, can we somehow get rid of this table? Okay, I'm gonna say, okay, to distinguish the SSN values, I'm gonna call this manager SSN value. Then I can introduce a manager things. Then can I just keep adding values here? Like worker SSN, worker things. Can I do that to capture that? You follow what I'm saying? You're gonna say something, go ahead.
No, you can't do that.
You cannot do what?
You have to have a new column per employee.
Yeah, because you have to do a pair of columns like that per employee, and you don't know how many employees end up working for that department. So there's no way you can fix this. And even if you do know how many employees are going to work for one department, the number of employees working for different departments is different, rendering this not a structured design anymore, because do I need to work 1 until work 10? But department A has 10 employees, but what if department B has only 5 employees? Suddenly you are wasting 5 parallel columns. Because of that, you have to cater for the worst case. That's why for many-to-many, this doesn't work. This only work for one-to-many. For many-to-many, You cannot do that. You have to do this. But for many, this is okay because I use a combination as a key. You can have any number of combinations, and the number of combinations for different departments can be different as well, so everything is fine. Okay?
Back to your one-to-many.
Back to the one-to-many, yes?
If you want to define what department the employee manages, if they manage one, you'd have to search through all of the departments to find it, right?
Say again.
So if you wanted to find a specific employee and find out if they manage a department, you'd have to search through all of the departments to find it.
So with this, you're asking a query question rather than a design question, which is ahead of us, but that's okay. Let's look at what you were asking. You were asking, if I want to find out if an employee is a manager or not. Okay? What I need to do is go through this and check whether SSN values show up somehow. If you don't have any facility structure whatsoever, you need to linearly scan through all department records. Yes? But oftentimes, if you think that's an important workload for you, and you do that workload all the time, you build something called an index over this. We will talk about this later on. It's a much more advanced topic. We will reserve this for later discussion. Yes?
So in this example, is there a separate manager and employee table? How do you know if a manager is both an employee and a manager?
No, there are no separate. There's the employee table, there's the working table, and there's the department table. That's it. The manager SSN value is attached to the department table. So there are only 3 tables for 2 entities and 2 relationship sets.
So does that mean that the manager...
Do you mind speaking louder so that...
So does that mean the manager SSN is not in the employee table?
It is in the employee table. I just renamed this to make this more meaningful. It's just SSN value. The way you can tell that is this is also a foreign key. Reference back to the employee table so that you know this actually is the same SSN value from the employee table. All right, so that's that. Finally, I'm going to talk about total mathematics. What if I bold this? When I bold this, this means this is no longer allowed. Do you follow that? Okay, fine. I'm always happy to do this. If you ask me to assign someone to a manager, I'm more than happy to do it. Okay, let's do it. So that's good news. People always love to hear good news. People don't like to hear bad news. Okay? You want to assign somebody to a manager, you don't want to do it, let me do it. You want to revoke somebody as a manager, don't ask me to do it. Somebody else's job, not my job. Okay? So bold, on this hand, fantastic, no problem with it. But how do you reflect that in your design? How do you reflect that in your design? Yes?
There can be a null attribute.
Yes, you add a constraint to the manager SSN attribute, say this must be not null. Because the default value is null, right? You say, okay, fine. Your default value cannot be null. You have to specify a value. When you insert a department record, you have to specify an SSN value. That's it. You follow the argument? But note that this says nothing about whether somebody needs to be a manager. Because this only says, okay, for a department record, the SSN value, the manager SSN value must be not null. But it says nothing about whether an employee SSN value must show up as a manager SSN. It actually says nothing about that. So it's fine. You may wonder, okay, speaking of which, what if I want to do this? Well, this is the organization you're going to work for, right? Every employee is a manager. Okay, that employee goes bankrupt in no time. Everybody just talk, nobody do the things. Right? That's what happens. If everybody is manager, everybody talks, nobody does things. But let's say I want to do that. Is there a way I can capture that using my design? Go ahead.
In order to design, no. I think you would have to add either to the employee table,
Okay.
the department entry, because then you would have to enforce that entry can be null, or you will have to have the extra table.
Okay, fantastic. Let me recap what he said. He said 2 things. One is current design, no. Obviously, you cannot capture that. One possible fix. Can we add department ID to the employee table somehow? and make it not null so that whenever you insert employee, you have to have a department ID value, meaning you have to be a manager. Sounds reasonable, really good attempt, but unfortunately it doesn't work for the following reason. It's many for the employee, right? So how many BIDs you should add? You don't know. I could be manager 1, I could be manager 2, I could be manager 3 or 4 or 10 different departments. In a schema like that, in a structured design, how do I figure out this? And the number of department ID attached to different employee record is different as well. One employee can be one manager, the other employee can be manager of 3 departments. Do you see the problem? So the fix we propose helps solve this problem, meaning enforcing that every employee in the department is a manager, but at the same time they introduce other issues with it. So we cannot do that, but very good attempt. So how do we fix that? Stay tuned. We have to talk about constraint checking later on in order to enforce those more advanced constraint types. Okay? Similarly, in order to force this total participation constraint, meaning every employee work for a department, every department must have some employee working for it, even though it's a managed menu. How do I fix that? Can I just say not now here as a fix? Does it capture it? Obviously no. It only says everything appear here must have a SSN and DID value, but it doesn't say anything about every SSN must appear here, every DID must appear here. It says nothing about that. So how do we fix those? We need to use more advanced machineries. You cannot do this, okay? Literally, you cannot do this. Like, go from here to Provo, take a car, take a bike. Go from here to Boston. Well, arguably, you can still take a car, take a bike. Okay, go from here to Mars. Good luck with car or bike. Doesn't work. No matter how many cars you have, no matter how advanced your car is, BMW, whatever you want to try, not going to get to Mars. Okay, that's the point. Now, what about hierarchy relationships? Yeah, do you have some minutes? For hierarchy relationships like this, there are really 2 choices. One is you stick with what we said earlier. Every entity set goes to a table. That's still true. Every entity set goes to a table. So you have 3 tables. You have 3 entity sets. You have 3 tables. The only minor adjustment you will have to make is those children entity sets do not have keys. They inherit the keys from the parent entity set, right? So when you create the tables for them, you take the key from the parent entity set down as the key for the children tables as well. That's it. And each table has their own attributes, just like we have in the ER diagram. That's choice number 1. Choice number 2 only works if the covering constraint is true. Recall what's covering constraint? If I have the union of the 2 entities that cover everything from the parent, then in that case, you have the option of not creating 3 tables, but just creating 2 tables. Because the covering constraint is true. You create our employee table and contract employee table. And in this process, you take the attributes from the parent entity set and place them into that children table, meaning that you end up with this. Okay? So you have these 2 options. If the covering constraint is true, oftentimes you go with the second option. If covering constraint is not true, you have to go with the first option. You have to have 3 tables. Finally, what about ternary relation? That goes back to what you asked earlier. What about that duration? Well, for ternary relation set, the rule is the same. You convert that ternary relation set into a table, and you take the keys from all participating entities into that table as the key. In this case, all participating entities meaning 3 entities. So you take 3 keys. The combination of them become the key of the relation set. Finally, I give you a summary, kind of like a cheat sheet kind of thing. Entity goes to a table. Many-to-many goes to many-to-many relation set goes to a table itself with the combination as the keys. This is many-to-many. What about one-to-many? One-to-many, you could have done this, but we talk about this is wrong. You cannot do the first one. You need to fix the keys, right? So instead, what you should do is just ignore R1 and add the key from E1 from the 1 side and place that into the E2 side. So you end up with that table. So I have a detailed summary like this over here. Okay? For one-to-one, you treat it as either one-to-many or many-to-one. In Zero, you have two choices. Ternary, you create 3 tables for 3 entities and 1 table for the relationship set, taking the keys from all participating entities. Finally, what about aggregation? Aggregation is very much like the way you treat a ternary relation set. All 3 entity sets still go to separate tables. And that normal relation set, you just do whatever you need to do, whether it's many-to-many, one-to-many, you do whatever you need to do. The aggregation, you treat it like a ternary relation set. It goes to a table itself by taking the keys from all involved entities, as well as relationship specific attributes go to that table. That's how you treat aggregation. I think that's all. All right, good luck with your homework one. See you on Wednesday. Yes,